Now I'm continuing with the Unit 2 topic. So the Unit 2 topic, before going to that, let us see what is the topic. So the Unit 2 integrity constants over relations is over. Next topic is enforcing integrity constant. So coming to this. So the topic is enforcing integrity constant. Integrity constant short form is IC are specified when the relation is created and enforced when a relation is modified. So when the table is created and when it is modified, integrity constants has been specified. So the impact on domain, that is domain, the primary key, the unique constant is very straightforward. If an insert, delete, or update commands causes a violation, it will be rejected. The following insertion violation, the primary key constant because there are already a tuple which is SID, that is student ID number is 53688 and is rejected by the DBMS. How? Insert into student SID, name, login, age, and GPA. Values are 53688. The name is Mike, and the login is Mike at the rate of EE. Age is 17. GPA is 3.4. So the following insertion violates the constraints that the primary key cannot contain null. For example, insert into student SID, name, login, age, and GPA. Here the values are null. Mike at the rate of EE 17.3.4. Here what we are seeing, here the value is there and here is null. So this is a constraint and this cannot be permitted. It is violating the protocol, DBMS protocol. So next, this update violates the primary constraint because there's already a tuple called SID of 50,000. Now, update student s.set s.sid is equal to 50,000, where SID is equal to 53688. The next topic is query relational data. The relational database query, for short, it is a question about the data. Query means is a question. That is about what the question is regarding the data. And the answer consists of new relation containing the result. For example, the syntax is as follows. Select star from table name. That means we are selecting everything from the particular table. Next, select particular column 1, column 2, and so on from table N where the condition is. The condition is fulfilled, then this particular columns from this table name can be selected. For example, this is a syntax and this is an example. Select star from customer where country is equal to Mexico. That means when the country only is Mexico, then we can select the customers, all the customers. Star means all. Asterisk means star means both are same. Next, select country from customers. That means we are selecting everything. What are the operators in the where clause? So the following operators can be used in the where clause. Is equal to is called equal, greater than, less than, greater than equal to, less than equal to, not equal, between a certain range, like a pattern in operation, which is used in the unions, in, out, outer joints, and which is all used in the outer joints or in join or something like this, used in joints basically. The next topic, what we are going is logical database design. Logical database design is first entity relationship to relational. How we can do this? Entity sets to tables, relationship sets without constraints on two tables, translating relationship sets with key constraint, translating relationship sets with participating constraints, translating weak entity set, translating class hierarchies, translating ER diagrams with aggregation. So these conditions or the rules comes under the logical database where we can entity relationship can be translated to relational database. Now we are seeing one by one. Now entity set to tables. What is that? Entity sets to tables. An entity set is mapped to a relation in a straightforward way. Each attribute of the entity set become an attribute to the table. So the entity set is there. Entity set means the whole thing is called entity set. Is mapped with the relation. This is called the relation. The combination of rows and columns and with the headers and the tuples and the attributes. So this is nothing but the relation. So what happening is, it's just, so each attribute becomes the attribute to the table. So each attribute, what is this SSN, becomes a header. So this is this is the attribute and this is nothing but the header. Next comes the name. This is all attribute and this becomes the header. So this is next comes the lot. Lot comes under the header. So these are nothing but the whole thing is nothing but the header. Here the table. Here we are heading with SSN, name and lot. So this whole thing, horizontal row, is called a tuple. The vertical column is called the attributes. Okay, the values inside this table is called the domain, where is related to some other thing is called the, some other relation or a table is called the range. So these are the SSN number. So this is the content, how the entity set is converted to a table. The first concept is that. The second one, relation set without constraints to table. To represent a relationship, we must be able to identify each participating entity and given values to the descriptive attributes of relationship. Thus, the attribute of relation include the primary key of each participating, whose that entity set as foreign key fields. Next, that means the primary key of one table can be a foreign key of the next table. That is the child table. You can tell that indirectly. So that is called a weak entity. So descriptive attributes of relationship set. Next, we can see the ternary relationship set. Ternary means having three. This is the relation. Relationship is represented by a rhombus. Rectangle is represented by for the entity. The attribute is represented by the oval. So these are the lines. It can be so many one to one, one to many, many to one, many to many. So these are this underlined underline line under this header is called the primary key. So for this is the primary key. For this is the primary key. All the available information about the work table is captured in the following SQL definition. Create table work, SSN character of 11, DID is of integer type, address character of 20, since the date is reserved, and primary key SSN, DID, and address. SSN is the primary, DID is the primary, address is the primary key. For this, we have a underline. So this is the primary key. Foreign key, what is this? For this table, SSN is a foreign key for the employee. For the employee. Next, for this table, this is a foreign key. For this one, this is a foreign key. So, foreign key of address. Address is a foreign key for these two tables, referencing location. So, which is a location here? So, this is a location. Foreign key of DID references department. So, this is a foreign key which is referring to department to the other two. Next, the third one is nothing but a translating relationship set with key constraints. If a relationship set involves n entity set and some m of them are linked via arrows in the ER diagram, the key for any one of these m entity set constitutes a key for relation for which the relationship set is mapped. So that means there are n entity with some m and it's linked via arrows in the ER diagram. The key is one of the main member of the entity set, which consists of a key for the relation of the relationship set and which is all mapped together. Thus, we have m candidate keys and one of these should be designated as a primary key. Let's see for this example. The employee manages the department. In the employee SS1, and these are nothing but the attributes. So here, your manager working since which date? Next, the department is having DID, D name, and the budget. And yes, employees having SS name, SSI, SSN name, and this is nothing but the IoT. So what is the command for this? SQL or DBase command. Create table managers, SSN of character 11, DID of integer, since date, primary key is DID, foreign key is SSN, difference is employees. So this is a foreign key which referencing to employees, foreign key of DID referencing to department. Here the semicolon should come. Okay. Next, translating relationship with participation constraints. So you see the employees having SSN, name, and IoT, manages since the date, and works in department, DID, D name, and the budget. So for this, we're creating the table. So for everything, there's a semicolon here. That is the end of the DBMS statement. Create table, department manager, DID of integer, D name of character, budget of real, assistant character level not null, since date, primary key of DID, foreign key assistant differences employees, on delete no action. Translating weak entity sets. The weak entity set always participating in a one-to-many binary relationship and has a key constant and the total participation. This is the total participation with the dark lines. So the syntax is create table, department policy, P name character of 20, age of integer, constant of real, SSN of character, primary key is P name and SSN, foreign key SSN, references employees on delete cascade, translating class hierarchies. So you see, this is one level, this is another level, and this is the sub level. So this is a hierarchy, one level, second level, third level, and so on. We present the two basic approaches to handling is a hierarchy by applying them to the ER diagram shown in the figure. Employee SS name and IoT is a relationship with the hourly employees and the contract employees. Contract employees are from contract and hourly is hourly wages and hourly work. Translating ER diagram with aggregation. You see all this relation, they are one entity relation with another entity, that is project sponsors department. In the project, it is nothing but project ID, name, and the budget. This is nothing but the since command, department IDs, department name. This all can be aggregated to form one big entity. So this is called aggregation. Now the diagram will be the employee SSN name and IoT. This monitors this whole entity, not the individual, the internal parts in it. Will monitor the whole entity, where whole entity is a combination of all these actions and the active members of this. So this is called aggregation. Aggregation is a combination of many events or many relations or many attributes to come to become one big entity. So this is nothing but ER diagram with aggregation.